My name is Bella Ann, and my solo work on this research project, Personalized AI-Powered Storytelling for Dementia Care, could be the next intervention for dementia. Dementia is a progressive condition that compromises cognitive function and emotional well-being, diminishing quality of life and sense of self. There is no cure, but interventions exist to improve quality of life. The symptom of dementia is short-term memory loss, which leads to distress, but long-term memory stays intact. Reminiscence therapy, a non-pharmacological intervention where individuals recall and share memories about their life, has shown promise in supporting emotional and cognitive well-being for people living with dementia. By leveraging emerging AI tools, these memories can be transformed into personalized multimedia digital stories to encourage reminiscing independently. The purpose of this project is to examine the feasibility of using AI to create personalized digital stories from individuals' memories, as a novel tool to enhance reminiscence therapy in dementia care. To create these personalized digital stories, here's the process that was followed. Interviews structured similarly to a reminiscence therapy session were conducted to gather a wide range of memories. Questions relating to childhood, relationships, and present-day life were asked to create multidimensional stories. The interview transcripts were then given as input to various machine learning models to generate multimedia outputs for the stories. The large language model, Mistral 7B Instruct, which is a model trained to generate human language, was used to find themes in the memories and to generate memory summaries. The summaries were then narrated using Cookie TTS, in a male or female voice depending on the individual's preference. The web version of Gemini was used to generate images of events in the memory. All the different machine learning model outputs were then combined into a multimedia digital story. Here is a snapshot of an example story. The performance of the models and the overall story were evaluated through human review from the participants. Here is a summary of the evaluation questions that were used to determine accuracy, completeness, and clarity of the summary, images, and overall story. Summaries were generally accurate and aligned with participant narratives. However, errors were present in the AI's interpretation of the original text. Visuals reflect events, but miss specific instructions or contextual details, and contain visible artifacts, which are imperfections or distortions. Through reprompting, images typically improve. Testing was conducted with people from the University of Calgary's Healthy City Lab, who were in their 20s and 30s. Clarity and accuracy scored lower due to discontinuity, errors, and inconsistencies in the interpretation of the memories, while coverage scored the best, meaning most events from the memories made it into the summaries. In general, the events were summarized in the correct order, resulting in a continuous and consistent plot. Photorealism scored the best due to the realistic appearance of the images generated, while image quality and caption matching had lower scores due to artifacts and prompt adherence, respectively. Overall, all participants found that the stories captured their memories in a visually appealing way. This proof of concept on younger participants from the lab demonstrates the feasibility and engagingness of the overall approach. Participants responded positively to the storytelling experience, suggesting potential for emotional and cognitive benefits. Despite the relative success of the testing, there are quite a few limitations. Currently, there is significant human involvement in the story creation process due to having to conduct the interview and pre-process its data before inputting them into the machine learning models. The large language model used hallucinates new information, interprets content incorrectly, exaggerates events, elaborates unnecessarily, and uses complex language at times, which are all common flaws of these kinds of models. The images that were generated from the text-to-image model miss details from the prompts and have artifacts. The next step for this research is to conduct a case study with individuals living with dementia to see if the test results are reproducible with the target population. In the future, automating the interview process with a large language model chatbot will reduce human involvement significantly. This research introduced me to the positive impact and potential of AI applications in the healthcare industry. AI offers a scalable method for generating personalized digital stories to simulate reminiscence therapy. With further refinement, this approach could help expand access to meaningful, low-burden interventions for individuals living with dementia in both clinical and home settings. These are the resources I consulted. I would like to thank my supervisor, Dr. Sayed Bayat, for providing me with this opportunity, and the lab manager, Dr. Shahab Alizadeh, and the rest of the lab team for their support. I would also like to acknowledge NSERC for providing funding for this research. Thank you for listening to my presentation.